What's the connection between asking an AI to write an email and the lights flickering in a town hundreds miles away? You'd be surprised. The AI revolution runs on electricity, and we are quietly approaching a breaking point. The invisible infrastructure powering our digital world is starting to buckle, and almost no one is talking about it.
When I use ChatGPT or Midjourney, it feels so ethereal, like magic. The answers just appear from the internet.
It's a powerful illusion. We call it the cloud, which sounds weightless and infinite. But that's just a marketing term for someone else's computer.
And that someone else's computer is actually a massive physical building, right? A data center.
Exactly. Tens of thousands of them in nondescript buildings all over the world. But we've been lulled into thinking of them as a utility that's just there. The surface story is that AI is just software, a new app on your phone.
But the truth is, this new kind of AI requires a completely new kind of physical infrastructure, and it's incredibly hungry.
To understand the problem, you have to see that an AI data center is a different beast from a traditional one.
How so? I picture endless rows of humming servers in either case.
You're right, but it's what's inside the servers that's changed. For decades, data centers ran on CPUs, central processing units. They're generalists, like a Swiss Army knife, good at many different tasks sequentially.
But generative AI is different.
It requires GPUs, graphics processing units, thousands of them networked together. A GPU is a specialist, like a sledgehammer. It does one thing, parallel processing, with brutal efficiency. Training a large language model is like performing trillions of calculations at once, and that's what GPUs are built for.
And swinging a sledgehammer takes a lot more energy than using a Swiss Army knife.
A lot more. A single server rack with high-end GPUs can consume 50 to 100 kilowatts. A traditional CPU rack might use 7 to 10. We're talking a 10x increase in power density.
So you have a double whammy. You need more servers, and each server consumes vastly more power. And all that power generates immense heat that requires even more power for cooling.
Precisely. Utility companies that plan their grids decades in advance have never seen localized demand like this. They're being asked to supply a small city's worth of power to a single building, and they're being asked to do it tomorrow.
Okay, so it's power intensive. But how big is the problem, really? Give me the data.
Let's look at the growth. Before 2022, U.S. data center electricity consumption was fairly stable, growing at maybe 2 to 4% per year. Now, the IEA projects that by 2026, data centers will consume more electricity than the entire country of Japan.
That's a staggering increase in just a few years. Where is this demand concentrated?
In data center hotspots. The most famous is Data Center Alley in Northern Virginia, which handles an estimated 70% of the world's internet traffic. In 2022, the local utility, Dominion Energy, had to announce it couldn't meet projected demand. They literally paused new data center connections.
The grid, in the most important digital hub on the planet, is already at capacity?
It was. They're now scrambling to build new transmission lines and power plants. And it's not just Virginia. Georgia Power recently forecasted that 80% of its future electricity demand growth will come from data centers. Utilities in Arizona and Texas are saying the same thing. They're openly warning in shareholder meetings that they can't build infrastructure fast enough.
So this isn't a theoretical future problem. It's happening right now. Okay, let's connect the dots. The grid is strained. Why does this matter to me or to the companies we work for?
There are 3 direct consequences. First, your wallet. When electricity demand skyrockets and supply can't keep up, prices rise for everyone. Utilities are investing billions in new infrastructure, and those costs are passed directly to residential and commercial customers.
So my home energy bill and my company's operating costs are both going to increase to subsidize AI's growth?
It's already starting to happen. Second, it's a major roadblock for the green energy transition. Renewables like wind and solar are great, but they can't be built as quickly as a new gas-fired power plant. To meet the urgent 24/7 demand of these data centers, utilities are delaying the retirement of coal plants and fast-tracking natural gas plants.
So the race to build AI is actively slowing our progress on climate goals. That's a serious trade-off.
A very serious one. And third, it's about economic competition. Power is a finite resource in any given region. If a new hyperscale data center campus gets approved, it might consume all the available power in the local grid, meaning a new EV battery factory or a semiconductor fab can't be built there. It creates an energy bottleneck that can stifle broader industrial growth. So, the magic of AI isn't magic at all. It's a machine, a factory for intelligence, and it has a voracious appetite for power. This isn't a reason to be anti-AI, but it's a critical reality check. The exponential growth in AI capability is on a collision course with the linear, slow-moving world of our physical infrastructure. The companies that solve this energy problem through more efficient chips, better cooling, or new power sources will be the true winners of the AI revolution. The rest will just be paying the bill. If you want more analysis that cuts through the hype to what actually matters, subscribe to Decoded AI. Our next video dives into the massive water footprint of these same data centers, another hidden cost of the AI boom. That's the signal in the noise. AI Decoded.